Assalamualaikum and a very good day to all of you. As I mentioned, this is our final class. Okay, so for today we are trying to cover another two topics. Okay, the first one will be on construction noise monitoring, measurement and abatement, and the other one we are going to look at on calculation, construction noise prediction, right? Okay, as usual, this is our quick chat. All right. So previously we have covered construction noise issues and management. Right? And then last week we also have covered on this topic on construction noise propagation. And these are the two topics that I mentioned just now. Okay, supposed to be we are going to cover these two for today since this is our final class. Okay, because if I'm not mistaken, next week will be study week, right? Okay, so for the previous notes and also video recording, you may refer to e-learning. Okay, and then that's for the topics. For the assessment, okay, after the class, to this class, I will upload the group assignment, the question for the group assignment. So hopefully all of you can assess the assignment, the question, and the deadline will be on, I think, on 8th of February. Okay, so the details you may refer to the e-learning. Right? So hopefully so far all of you quite clear regarding the topics and also the assessments, right? So if you have anything to ask, you may ask me, okay, right away, or maybe you may contact me through WhatsApp or email, right? So is everything okay so far?
Okay, Doctor.
All right. Okay. So without further ado, I think we can proceed to our class. All right. So for today, for the first topic that we are going to cover, which is construction noise measurement. Okay. This is the several subtopics. Okay. As usual, I would like to present this outline so that we have a view or overall view regarding the topic that we are going to cover, right? So the first one we are going to look at on the purpose of construction noise measurement. Why is it necessary for us to conduct the noise measurement? And then for sure for us to conduct the measurement or the monitoring, we need to have appropriate instrumentation or the equipment for the measurement. So we are going to look at on the related instrumentation. And then in terms of the measurement, meaning that how we conduct measurement, the way we conduct the measurement, okay, I will share on that too. And the next one will be on noise level assessment, and the last part will be sound level databases, right? Okay. So for the first subtopic related to the construction noise measurement, we need to know the purpose, right? The aim or the objective on why we need to do the measurement, right? So in general, noise measurement is needed in order for us to determine the background noise level, meaning that the ambient, okay, ambient noise level for a certain surrounding or environment, maybe the location, okay, specific location that we are going to measure. Okay, so that's why we need to determine the background noise level. And then information of noise from equipment. This one mostly from the individual equipment. For example, if it is from construction site, so we are going to measure the individual construction plant and machineries involved for a certain construction activities, right? So based on the measurement, we are going to get or to obtain this information. And then for sure we are able to know the level of construction noise operation. So this one more on sound level. Okay, we need to know the sound level for each of the construction noise operation. Is it the activities is categorized as noisy? Okay, we need to know the exposure level as well as noise from other sources. Okay, for example, if the let's say the construction site located close to the traffic area or roadways, so we try to measure the other noise from other sources. It can be from manufacturing industry, okay, nearby factories, and the other related sources, right? So this measured noise level we use to determine the anticipated community response and impact of the noise. Okay, these are two main component here. We can determine the anticipated community response and also the impact of the noise. Okay, so basically this one will be related later on to our calculation. Okay, so in overall, this is the purpose or the need why we need to conduct noise measurement. And this one especially for the purpose during the planning stage. Okay, because the consultant, the other related parties are what we call are concerned on this anticipated community response and also impact of the noise for their actual construction activities. Okay, they are going to predict prior to the construction. Okay, so that's the purpose. The next one, we are going to look at on the required instrumentation. Okay, as I mentioned just now, for us to conduct the measurement, we need to have this related instrumentation or equipment so that we can carry out the measurement of sound level in a appropriate way. Okay, so basically all of the topics subtopics for this one quite relate to our calculation later on. Okay, for your information, in order for us to conduct the sound level measurement, okay, construction noise measurement, so we need to have this main instrumentation, okay, main equipment, which is sound level meter. So I would like to ask whether any of you have ever used this equipment previously. Okay, any of you? Okay. From this class?
No, no.
No, all right. Okay, it's okay because I will share on how actually this equipment works, all right? So this is the main equipment for the sound level measurement, okay, which called as sound level meter. Right, so here we can see that we have two different types of sound level meter or two categories. The first one we have type 1, okay, and then the other one we have type 2. All right, so these two types of sound level meter are very common and required by the authority or according to the regulation because each of these instruments what we call appropriate to be used for the sound level measurement. Okay, for the first one, type 1 sound level meter, as the name mentioned, type 1 sound level meter usually will it is categorized as type 1 because due to the what we call the calibration value, okay, meaning the accuracy value because this one is plus minus 1 decibel, okay. If you still remember that the unit of sound we are going to use is decibel. Okay, so the accuracy value is within plus minus 1 decibel. As compared to type 2, this one the correction value is plus minus 2 decibel. Okay, in terms of its accuracy. Okay, so in overall, type 1 is more accurate or detailed as compared to type 2. Okay, this is actually the main difference between these two types. Okay, so it is easier for us to remember because type 1 with plus minus 1 decibel and type 2 the accuracy with plus minus 2 decibel. Okay, that's the main difference between two instrument or two types of sound level meter. Okay, apart from that, the other difference is that related to the ability of the instrument itself to measure specific data. Okay, for example, previously I have mentioned related to the SPL, sound pressure level, and also frequency. Okay. So most of sound level meter type 1 are able to measure these two main parameter of sound pressure level and also frequency as compared to sound level meter type 2 because most type 2 sound level meter unable to measure frequency. Instead, only SPL are available to be measured using this type 2. Okay, that's the other difference. Okay, the other difference that differentiate these two equipment, okay, these two type 1 and type 2, right? So hopefully, since all of you never use this equipment, okay, at least this is what we call additional information, new information to all of you so that you are able to differentiate and are able to identify which instrument suitable to be used for construction noise measurement and also the other types of measurement, right? Okay, apart from that, this is the description just now related to the type 1 and type 2 sound level meter. Both are accepted by DOE, Department of Environment, for noise monitoring and measurement purposes. Okay, so these two, as I mentioned, are accepted or acceptable by the local authority. Okay, since for sure the type 1 the most accurate one, type 2 still acceptable since the accuracy is within plus minus 2 decibel. All right. And this one I just mentioned just now. Type 1 is able to show SPL in dB and also frequency data. Frequency either in octave band 1/1 or 1/3 octave band. Okay, all of this information I have covered in our previous class. So you may refer back again to the previous notes, lecture notes. Okay, try to relate everything. And for the type 2, it can only measure SPL, right? Okay, that's the difference for your information. Okay. Okay. So this is the example on how we set up the instrument, okay, the equipment, which is sound level meter on site. Okay, here we have this figure. Actually, this is the what we call noise monitoring at construction site, which is nearby to Aeon, Taman University. Okay. Now we have this what we call this construction project is actually for the building that besides the Aeon, which is Eco Shop, Family Mart, and so on. This is the site actually. Back in 2000, if I'm not mistaken, 2000, maybe 2013 or 14. Okay. All right. This is actually based on my previous study, right? Okay, so based on this figure, we can see that this is how we set up the equipment, the sound level meter. Okay, for your information, type 1 sound level meter is quite complicated, not complicated, it's quite detailed. It what we call well equipped with several kits and several sub-equipment. Okay, for the purpose of outdoor measurement, we have this outdoor weatherproof kit, okay, in this box. Okay, this box actually the weatherproof kit for the sound level meter, which is used to measure on-site construction noise emission level or other noise such as traffic noise, other environmental noise, right? So this is how we set or how the setting looks. Okay, we set the sound level meter, especially the microphone, on this tripod. Okay, to a fixed position. Usually, the height, you can see here that this height from the ground level is usually about 1.2 to 1.5. Okay, this we call the setting. Okay, the what we call the requirement is based on the DOE. Okay, it's already mentioned in the guidelines. If you want to proceed with the noise level monitoring, noise measurement, we need to set up the height of the microphone at this position, at this height, okay, 1.2 to 1.5. Okay, so in actual practice, this is how we conduct the noise measurement, right? Okay, so far is everything clear?
Yes, Doctor.
All right. Okay, so hopefully this will be what we call new knowledge for you, new information regarding construction noise measurement. Okay, so continue to that. As I mentioned just now, type 1 sound level meter as compared to type 2, it comes with the software or data logger. Okay, most type 2 just a standalone equipment. Okay, just a simple equipment with ability to capture the instant reading instead of to log all the data or all the information to the data logger. Okay, so this is example of software for type 1 sound level meter. Okay, once we have settled with the measurement, all the readings will be stored in the data logger with large memory of sound level meter to store the required information, and for sure it have its registration number or the tracking number that we can trace our data. Okay, for this one, okay, the one that I show you just now, the model is Pulsar. Okay, for Pulsar, we have the software, namely Pulsar Acoustic Toolbox. Okay, maybe you can search for this one. It is one of the established model or established brand for sound level meter for detailed analysis or detailed sound level measurement. Okay. Based on this software, we can store the data, and then we can trace back the data, and it will automatically come out with this related charts or related plotting for the purpose of noise monitoring and also noise measurement. Okay, I think that's all for the sound level meter. The other important instrument related to sound level meter, we should have a calibrator. Okay, calibrator is another instrument required in order for us to have a good results for noise noise measurement. Okay, so I'm sure that all the other instrument also have its own calibrator so that we can avoid any reading error. Okay, So this device is important to be used in calibrating the sound level meter before and after the measurement. Okay, so we use this calibrator to what we call to calibrate again the reading value. Okay, so that we can have a good result or a good measurement result. Okay, each model supposed to be has its own calibrator, which allow the users to quickly check the accuracy, okay, of the sound level meter and its compliance with the regulation. And for your information, type 1 sound level meter, this is the calibration value, 94 decibel plus minus 1. Mean this is referring to type 1 sound level meter. In order for us to have a good validation of the accuracy. And since it is plus minus 1, so the acceptable calibration reading will be in this range, 93 to 95, right? So that's another information related to the noise measurement. Okay, it is very essential, it's very required for us to calibrate first the equipment before we proceed with the measurement. Okay, that's how the procedure related to noise monitoring. Okay, the next one, the other instrumentation that we need to do the measurement is meter. It is a meter to measure the distance or the dimension, length, height, and so on. Okay. So this meter will be used for the noise measurement in terms of to measure the required distance, especially between receivers and sources. Okay. This one is the main what we call main information that we need before we proceed with our measurement. Okay. And we need to know the distance between the receiver and from any reflecting structural obstacles. Okay, so this one we are going to relate in our next calculation. And for sure, we need to know the height of sound level meter and microphones, okay, and height of the sources. Okay, this one, as I mentioned just now, is within this range, 1.2 to 1.5 meter, according to the guidelines by DOE, right? Okay, so the rest are the information related to the distometer. Usually the measurement accuracy is in the range of 1 millimeter, range up to 200 meter. Okay, it's depending on the model, on the brand itself. Okay, and this instrument can be used both indoor and outdoor light measurement, dimension measurement. Okay, this is just a brief information related to this meter. Right. Okay, the next one we have anemometer. The anemometer actually, apart from sound level meter as the main instrument for the sound level measurement or noise measurement, then we have this meter to measure the related length, related height, and then we need to have this one, anemometer. Okay, so basically, in measuring the noise level or sound level for a certain situation or certain environment, the meteorological condition should be considered in a location which normally has strong winds. Okay, this is related to the wind effect. Okay, these effects are more significant at greater distance from the noise source. Okay, so meaning that the larger the distance between source and receiver, this factor becomes more significant. Okay, so that's why we need to measure the wind speed, especially. Okay, and then these include wind speed gradient, wind direction, and temperature lapse rates. Okay, several factors that should be considered in the measurement of both background levels and also construction noise events or activities. Okay. However, in actual practice, at least we we need to measure the wind speed and also air temperature, because that two parameter already what we call required or included in the ISO. Okay, so we need to measure these two main parameters related to the meteorological effects, right? Factors. Okay, this one I mentioned air temperature and also wind speed at the height of sun level meter. So we need to place the anemometer at the same height with the sound level meter, okay, the microphone, okay, so that we can measure the wind speed, the current wind speed during the measurement. Okay, so this is actually the figures showing the, on our left side we have this anemometer, okay, anemometer, and this one for dystometer. Okay, this is how this instrument looks. Okay, for anemometer we can hold this main body and then place this probe, anemometer vent probe, at the same height with the sound level meter's microphone. Okay, so in overall this is on how we want to operate this one is quite simple. Okay, as long as we know the function, we know the way, the correct way on how to operate and on how to set up the instrumentation. Okay, all right. So that's all for the required instrumentation. Is everything clear? Okay. All right. Okay, so we are going to proceed to the next one. Next one we have, okay, this is the components or items that usually needed for the noise level measurement. Okay, here we can see that the stages, meaning that the phases that we actually need the noise level measurement. Okay, the first one prior to construction. Okay, this is the first one. Second one is during the construction. Okay, the first one is necessary for us to conduct because this is related to the planning stage. Okay, during the planning stage, the local authorities requires the developer or any related parties that intends to construct any activities, any buildings or any project need to have this noise level prediction or noise level monitoring, so that during the planning stage they are already aware with the anticipated community response and also the potential effects or impact to the nearby community, especially nearby residents, and also for example we have residential area, primary school, okay, any sensitive residual. So that's the purpose or that's the requirement why we need to do noise monitoring prior to construction. Okay, so at the earliest stage we already know the anticipated or predicted level of noise or sound level. Okay, so we can see here that for the purpose of noise measurement or sound level measurement prior to construction, most of the time we will conduct at these three position, visible position, at the boundary, at the residence premises, and close to the human activities. Okay. Okay. And then for the noise measurement, we should conduct background noise level or ambient, as I mentioned. And if you still remember, background or ambient level refers to this noise index, L90. So if you ever see any what we call any index with L90, So it's referring to background or ambient level. Okay, and then by having this measurement, we can establish the value for L90 for this position or for this location. Okay, later on I will share some figures, okay, for the receiver position. And then for the latter part, okay, during the construction especially, we still depending on the requirement, depending on the scope of the project or the condition, we need to further measure the noise in order for us to monitor and also to know the current or the exposure level during the construction. Okay, so this noise level measurement during construction can be divided into two types. Okay, the first one is for sure for the construction operation itself, meaning that we need to know the noise exposure level due to the construction activities being conducted or carried out during the progress of work, okay, at the construction site. Okay, this is the first category of measurement that we are going to conduct during the construction phase. And the other one related to the individual equipment. Okay, so the indicator or the index, sound index for individual equipment is sound pressure level. Okay, sound power level, LW. Okay, you need to differentiate. I think I have mentioned this previously. You need to differentiate between sound power level and also sound pressure level. This is the unit for each parameter, LW and LP. Okay, because this one again we relate to our prediction and also calculation. Okay. In terms of the position or the location that we locate the instrument, it can be at 1 meter and 10 meter. 1 meter is usually for the LW measurement, right? Okay, based on the measurement of construction operation, it can be based on the particular operation or multiple operation. Because as we know, in actual condition, we have several activities, construction activities or construction works progress concurrently. Okay, they are constructing the work concurrently. For example, the pilings works concurrent with the earthwork, so that's why we have this multiple operation with various types of construction plant and machineries. Okay. Okay, at the bottom part, we have several lists of example for construction activities. Okay, for example, we have the mention of piling at the early stage, and then at the end, we have this external works. Okay, it's this breakdown of activities depending again on the scope or the size of the project. Okay, and for the individual equipment measurement, at the end we can come up with the database, okay, and this database are going to be included in the standard, okay, as a reference, okay, as a reference for permissible limit for each of the equipment. Okay, so this is the description related to the previous figures. Some of the content I have mentioned just now. Okay, so the noise level measurement prior to construction is necessary again to evaluate the L90. Okay, at 3 selected receivers, this one, boundary, residence, and human activity. Okay, and for the purpose of this measurement, we are we set the equipment using fast time mode, response and awaiting. Okay, this one also relate back again with our previous topic. We have several types of waiting. So for now, I hope all of you already aware with this one. Okay, why we need to use awaiting instead of the other types of waiting. We have BC, D and Z, if I'm not mistaken. All right. And in terms of the mode for measurement, we usually use fast time mode, okay, which referring to the fast mode for the construction noise nature. And also this mode also can be used to measure traffic noise. Okay. So slow mode usually we use for low frequency noise. Okay, for example, it's going to be used in measuring the sound power level of manufacturing equipment. Okay, and then okay, the established background noise level at this stage prior to construction will serve as reference benchmark for reading of the LEQ or L10 associated with construction operation. So the predicted level or the measured level prior to construction will be used as a reference level or benchmark level, okay, for the latter part of the noise measurement. All right. So this is still a description related to the noise measurement prior to construction. Okay, later on all of you can go through each of these descriptions. So I think no need for me to read again each of these points. Okay, it's quite straightforward. All right. Okay. This is the figures examples for the receiver point. Receiver point for the first type of noise measurement during the early stage, during the planning stage, which is prior to construction. This is the measurement at the boundary. Okay, we have this holding to we call as a boundary between the construction site and the nearby area. And this is the second point for to represent the resident premises. And this is the human activities. Nearby human activities, this is the recreational activities, okay, close to the residential areas. Okay, and it is nearby the construction site. All right. So I think that's all for the noise level measurement prior to construction. Okay, again, this is the description for the noise level measurement during the construction. All right. By using the receiver point, just now we have early stage measurement. So by using the same receiver point, we try to reconduct the measurement, okay, so that we can know the current exposure level into the construction activities. Okay, so we can determine this LEQ that and also L10. And again, during this measurement, SLM should be set up to mode of fast time and also awaiting, right? Okay, this one related to the previous one, we need to measure temperature and also wind speed, okay, for the purpose to check whether there is effect on of the any weather effect on the readings. Okay, we have okay. Okay, this one also already mentioned just now. Construction project involve many different phases of stages of operation. So most of the situation, the works are being conducted concurrently. So that's why we have several or multiple sources of noise. Okay. So it is appropriate to evaluate and screen the project schedule of individual construction operation, okay, in order to determine in advance which construction operation is likely to produce the biggest noise. Okay, so that's why we use noise prediction, because the most based on the previous record or previous study, the noisiest stages of works is from substructures activities, okay, piling works and also earthwork, okay, as compared to superstructure and external works, right? By doing this measurement, specific construction operation that need noise monitoring can be identified. Okay, that's actually the purpose or the needs on how we need to conduct the measurement, right? Okay, again, the other description related to the noise level measurement during the construction stage. Okay. As I mentioned just now, piling activities, site clearance, earthwork, and this one substructures, other substructures, and foundation construction have higher tendency to generate high noise exposure level. Okay, this one piling activities and excavation may have significantly greater potential for noise impact as compared to the other construction activities, right? Okay, so the measured, what we call the measured or predicted levels, sound level, will be compared to the background noise level or permissible limit by the local authority, Department of Environment. Okay, so we need to check whether the measured value still within the allowable limit or not. Okay, all right. So the other one, the other thing is that it is equally important to measure background noise level, okay, at various intervals during the construction phase. So we need to measure the background noise level. Okay, so we can know the existing background noise level. So for your information, how actually we want to measure the background noise level is that we will measure the noise level during no activities conducted on construction site. Meaning that we need to measure the background noise level to represent the ambient without the presence of construction activities. So we need to measure before the construction activities start, right? Okay, so I think that's all for the what we call the noise level measurement for these two stages prior to construction and during the construction stage. Okay, so far is everything clear? Any of you have question? Anything to clarify? Okay, all of you still okay? Okay. Hopefully we can complete this. Okay, we can settle these two topics as for our final class, right? So later on we are going to cover on calculation part, right? Okay, the next one, another subcomponent for noise level assessment we are going to look at on these two items. The first one, noise level gain, and the other one we have noise impact. Okay, for the noise level gain, SPL increment may affect human reaction. Okay, this is very obvious. Okay, the higher the sound pressure level, so for sure it will have a higher tendency to affect the human in a negative way, either in cause annoyance or disturbance to the human daily activities, right? Okay, so any increment or any increase of sound level by 3 decibel is barely detectable by human ears. Okay, for example, the existing, what we call, the existing sound level is about 50 decibel, A-weighted, and there is increment of sound, for example, to 53, due to certain sources of noise or certain activities. So the difference between these two, 53 and 50, is only about 3 decibel. So basically, this value is barely detectable, meaning that it not really detected by human ear, and it will not affect or disturb our routine or our daily activities. Okay. However, 10 decibel changes or 10 decibel increment will for sure detectable by our ears and perceived by human ears as double of the sound, and it is very irritating. Okay, so if there is any increment from 50 to 60 decibel for sure, for normal ears, okay, human ears, it will be significantly detectable, right? So that's the difference in terms of the sound level increment, okay, on how it will be detected, okay, on how it will affect us, okay. And the other item is on noise impact. Okay, so noise impact assessment and anticipated community response, again, as I mentioned previously, are very essential in evaluating the noise. Okay, so we have these two components here, noise impact assessment and also anticipated community response. Okay, and how they perceive on how they respond to the noise level. Okay, so this is very necessary in evaluating the noise, right? So the assessed noise level is usually known as rating sound level, LR. So this one we are going to look at in detail later on how we want to calculate this LR, okay, which includes the correction for some characteristic to the measured noise level, okay. So I will share this one after this related to the rating sound level. Okay. Okay. This one we have the category, okay, the category of noise level gain, as I mentioned just now, in terms of the increment, in terms of the gain itself. Okay. If it is in the range of less than 0, for sure it is negative. So there is no description, there is -1. And then 0 to 3 is insignificant. Okay, as I mentioned, it will barely detectable and it is insignificant to human ears, to our ears. Okay, so if there is 3 to 5, there will be small, we call small detection by our ear, and then 5 to 10 is medium category, and this one is strong and very strong. Okay, so these two increment or these two noise level gain are the concern by the planner, by the related developer in predicting their noise level, okay, for the actual construction noise. Okay, because if we have this 10 or more noise increment, for sure, it will affect the community or the nearby residents significantly, which is very strong and strong. Okay, that's how actually it relates from the measurement to the prediction and also to the actual implication. All right. Okay, the next one we are going to look at on noise impact, as I mentioned just now, relates to the rating sound level, LR. Okay, so this is the simple formula to calculate the LR. Okay. In order for us to calculate the LR sound level, rating sound level, we need to know the LAQ value is continuous equivalent continuous sound pressure level with A weighted. So we have this LAQ as the noise index or the symbol, and then we need to plus with peak character if there is some peak character, and then we need to minus the duration. We need that duration of the sound exposure. So later on we are going to what we call to use this formula for our calculation. Okay, so LAQ, as I mentioned, this is equivalent continuous SPL with a weighted. Peak character refer to the correction value. This correction value can refer to this table. Okay, so most of the time peak character is represented by this one, impulsive noise. Okay, if we have any filing activities, so for sure we need to consider this correction value. We need to impose or we need to add additional 5 decibel to represent the peak factor of impulsive noise. Okay. Similarly, if we have the audible tone component present such as whine, this one most of the time are from excavator. Okay. We have lorry, so that one will be categorized as a spectrum character. Okay, low frequency noise, right? So we need to impose this additional 5 decibel in the calculation. And the other characteristic features of the sound related to the duration. Okay, duration, we need to know the duration of the sound so that we can include this correction value. If it is 100% percentage, so there is no correction. For the rest, we have this correction value. Okay, so later on we will going to look at this again, especially for the calculation, right? All right. So far, okay. Okay, semua. We have 35 of you. Supposed to be we have 40. 29 from SKAB5133 and 11 of you from MKAM1133 section 01. Okay. Alright, the next one. This is how we measure the noise impact. This is the information. The formula on how we want to measure the percentage of sound level rating. Okay, so in order for us to know the difference between the what we call the measured with the the expected, okay, the expected impact, we need to measure the changes of LR. So we are going to use LR just now from the previous one, okay, this one, and minus with the L90. Okay, again, any of you can describe L90 refers to what? Okay.
Noise.
Pardon? Sorry?
Background noise.
Betul. Okay. That's right. So you need always to remember that L90 refers to background noise or ambient noise level. Okay. Because it is 90% of the level, it represents 90% of the noise level during the specific time measurement. So that's why it's referring to L90 as noise index. Okay. So as for now, I hope all of you already remember this one. I have mentioned this quite several times. Okay. And then what we call the acid value quantifies anticipated impact and communication to the sound. Right? So we need to know whether this LR exceeded or not the background noise level. So again, LR refers to this one, rating sound level, LEQ measured, and then we have this L90. This is the description of this formula. All right. Okay, the next one for the noise impact. Once we have done with the calculation, we need to check the value that we able to obtain from the calculation, compare with this table established by the Department of Environment. So, for example, rating sound level LR exceed the noise criterion. For example, here we have 10 decibel weighted, and we can see that the impact will be medium, and the description for the anticipated communal response is widespread complaints. Okay, by having this medium impact, it will have tendency for the residents or any other community affected by the construction noise can file or complain to the can file the report or complaint to the authority. So that's actually how we need to predict the response so that the developer or the contractor can foresee this situation, right? Okay. I think this is the last part for our first topic today, which is construction noise monitoring and measurement. Here we are going to look at on this sound level database. So basically, as I mentioned just now, based on the individual measurement for the construction plants and machineries, it will be compiled for the sound level databases. Okay. So as for now, the main or the first comprehensive sound level database is in the UK, the Department of Food and Rural. I'm not sure. I can't remember the full name of this one, but we can try to check later on. The DEFRA in UK, okay, which is established in 2005, has categorized the database according to the types of construction activities and sub-activities. So based on these databases, based on these guidelines, it already published with this detailed information for individual noise exposure level for the construction plant and machineries. Okay. And then later on, according to the first established database, we also have this British standard. So British standard is another extension for the first database, which is quite a detailed data. Okay. It includes both UK historical and current data, and for the current data, it based on the ongoing research. Okay, they keep updating the information, the data related to the individual machineries related to the construction, and the historical data, which is mostly based on the previous one. So they have compiled the previous and the current data. So British standard become a main reference. Okay. This related reference I have mentioned in our previous class. Okay, you can try to look at again on the related acts and regulation for the construction noise. And then this one from the other country, especially United Kingdom. Okay, for our local reference, actually the data is very limited since construction noise itself at the earliest stage, at the beginning, we don't really concern actually. Okay, up until we have our guidelines, we have the regulation and acts imposed to the construction project. So it's become more crucial and become more what we call necessary for all the parties involved. So that's why we still have a very limited data, and we are currently updating the information. Okay, we are in a stage of updating and renew all the data. Okay, so that we can have a comprehensive data related to the sound level databases. Okay, so as for now, the available data is compiled based on relevant research, okay, which include the model, type, net installed power, and machine age. Okay, so this is mostly from the previous research, and the ongoing research are still being conducted so that we can have a better database for the local scope, right? And apart from that, we have Federal Highway Association also have come out with the prediction input for the construction noise. However, this one is specifically for the highways construction, and it also includes specific equipment and also operation related to the highways construction. Okay, so with that, I think it's all for the databases. The next one, this is the example. Okay, the example of sound level databases from BS, British Standard 5228, if I'm not mistaken. Okay, you can check it again. All right. So these databases has summarized or have compiled all the related sound pressure level of individual equipment according to the stages of the construction or types of the construction activities. Okay, the first one we have this clearing site, and then the other category we have excavation or earthwork. Okay, so the related equipment used for this specific construction activities were compiled so that it is easier for the practitioner, for us to refer. Okay, so that's why we have this. Actually, this is quite a comprehensive database, and it is the main, what we call main reference as for now. Okay. All right. So with that, I think that's all for the first topic. Okay, for the construction noise monitoring and measurement. Later on, we are going to look at on the construction noise prediction or the calculation part. Right? Okay. So before we proceed, I think we can have a break first. Is it okay?